Have you ever wondered how much money can be saved by making manufacturing processes more efficient? Something as small as reducing the amount of error in ball bearings by analyzing its defects and the forces acting on it can save thousands of dollars in manufacturing and machining. People are always interested in how to make things better, and the Machine Dynamics Research Lab, under the direction of Professor Eric Marsh, focuses on the characterization of error sources affecting machines to make them more efficient and save money.
For us, machine dynamics means making manufacturing processes go as fast as possible. It's easy enough to make parts accurate and smooth and so on, meet their geometry requirements when the machines are slow. But if you want to speed up the process, it's quite a bit more demanding, and that's where the dynamics part enters in. We tend to work a lot on vibration and the results of the machining. Our experiments typically measure force during grinding and metal cutting and so on, and we're able to use that information to feed back into the cutting process and make better parts. Yeah, in fact, most of our work is industrially sponsored.
Professor Marsh was unable to disclose the names of companies that the Machine Dynamics Research Lab is currently or has in the past done work for. However, from talking to Dr. Keller, we found out that many of these commercial companies come to their lab with questions that they need solved.
I have some undergrads who do things here, and then I have a postdoc who helps me run experiments. We have a couple of interesting, to me, videos. Actually, one of them has over 300,000 hits, which I can't actually explain why that is, but it's pretty fun. The equipment that we have in the lab is a little bit different than the machines you've seen in the Learning Factory or in the first floor of the Leonard building, in that our equipment is specialized in taking much lighter but much more accurate cuts, and so our equipment can make optical quality surfaces in certain materials. Materials like copper and aluminum and certain other non-ferrous, non-steel type metals can take on an optical finish. There's also infrared crystals like calcium fluoride and zinc selenide. You can have an optical finish coming off of a machine that looks like a lathe that you might see in the London building.
The history of this lab has really been for spindle metrology. Just means, again, how the spindle moves while it's spinning. But there's so many applications that, for example, if you have a machining process or a grinding process or a polishing process, then you can use those motions to get information about those processes.
Now the Machine Dynamics Research Lab divides their time between spindle metrology, precision grinding, and most notably diamond turning, where diamond-tipped tool bits are used for precision machining with elements such as crystals, metals, acrylic, and others.